Let's switch gears now and focus on logistic regression. This is such a fascinating topic to me because instead of predicting where a person will land on a continuous variable, we are predicting in which group a person will land. So for example, do we believe the person will pass or fail an exam? Do we believe that this a person who has been charged with a crime be designated as guilty or non-guilty? It's a yes, no, of course, in the court system. In research, we can make that a continuous variable, indicate the extent of guilt or the extent to which you agree that the person is guilty. But in real life, we have really a yes, no. We have a guilty versus not guilty. And so for that, we need logistic regression. We have life versus death. What is our prediction that this person will survive versus not survive? And of course, those are questions that are extremely important to be able to understand how we can help people to survive and have life and not death. Okay, so again, most of the research in our field has a continuous outcome. I think that's just easier for most people to do, and so they often design their studies that way. For example, we have number of days absent from work per year, or alcohol use, depression. All those are continuous outcomes that we've been working with. But when there's a dichotomous outcome, we need to use logistic regression. And so studies of diseases in the medical field, sometimes people want to predict, researchers want to predict whether someone will get the disease versus not get the disease. So there's no middle ground there. It's just either have the disease or not. Prison recidivism. So we want to predict whether an individual who is released will come back. Not the number of times they'll come back, but a yes, no. So they come back versus not come back to prison. So these are the kind of studies that will require a different approach than what we've been using. And so that's what I want to show you right now.